This question says the 6th term in an arithmetic sequence is 74 and the 7th term is 71. Find the 50th term. So the first thing we have to do is recognize this is an arithmetic sequence. An arithmetic sequence means that it's a type of sequence where you have some starting value and you are adding a difference to that every time. So we'll call that difference that we're adding a d value. So the second term has the d value added once, the third term has the d value added twice, and in the example that you see in front of you, we're adding 2 every time. So what that means is that the d value here is 2, and the a value, the starting value, is 1. So with those two things in mind, that's one example of an arithmetic sequence. Geometric sequences, on the other hand, are sequences that you start with a value. We're still going to start at, and we'll call it a, but then we're going to multiply by a value every time. We'll call that value that we're multiplying by r. So the second term is that starting value times r. The third term is that starting term times r twice, so r squared. So for example, I take 1, I multiply it by 2, I get 2. I multiply that by 2, I get 4. I multiply that by 2, I get 8, etc. So my r value there is 2, and my starting value is a equals 1. So this is an arithmetic sequence, and we're going to look at the general term now of that arithmetic sequence. The general term says that it's Tn, so that means what term number it is, and then it's a, the starting value, plus n minus 1 times d. Now that n is just the number term you have here. If that's applied to a geometric sequence, then we have a times r to the power of n minus 1. So now for the arithmetic, because that's the question that we have up above, let's focus in on that now and see how that one applies. So the first thing to keep in mind is that term 6 is equal to 74. We can write that in notation like shown, and term 7 is equal to 71. The difference between those terms, because they're subsequent terms, is this later term minus the previous term. So we could write it as term 7 minus term 6, so 71 minus 74. And so what that means is that we're subtracting 3 from one term to the next, all the way through the arithmetic sequence. So now we can go ahead and we can substitute the information from term 6 equals 74 and that d value into the equation, and the fact that we know everything except a means we can solve for a. So term 6 is equal to a plus 6 minus 1 times negative 3. Now that sixth term is 74, so we can also sub that in. And so it's a times 5 times negative 3. Well, that's just a minus 15, that's equal to 74. And so if we add 15 to both sides, we can solve that for a, and we get that a is equal to 89. And so from there, now we go ahead and we revisit the Tn equals a plus n minus 1 times d, but we can substitute in the a and the d value now. So the a is 89, and the d value is negative 3. So now I know I'm after the 50th term, so if I put n equals 50 into this equation, then I can go ahead and say 89 plus 50 minus 1 times negative 3. So that 50 minus 1 gives me 49, so it's 89 plus 49. And so really what we're doing is we're starting at that 89 term, and we're subtracting 3 49 times, which should make sense because every term that we go to after the first one goes down by 3. And so we get a final answer of negative 58. So we can conclude, therefore, the 50th term of this arithmetic sequence is going to be negative 58. If you had a geometric sequence, you would have done a very similar process. You could have taken the equation that you have there for the general term and subbed them in just the same way, but instead of adding or subtracting to rearrange the equation, you would have done some division. I hope that was helpful. For more on the arithmetic sequences, check out the video on the left. For more on sequences and series and the whole unit lessons on this, you can check out the video on the right. I encourage you to comment below on the trickiest type of sequence for you, and I'll look at more videos in the future on those types of sequences. Thanks so much for watching, and I hope you have a great day.